Thanks for coming to MOB301. My name is Michael Paris, and I'm going to be talking about how you can build mobile and web apps on AWS simpler by using some new tools that we've been working on over the past year, and even more in the past few months. So what are we going to talk about? First, we're going to talk about some high-level ideas of what web and mobile apps are, what you need in order to implement web and mobile apps, and specifically how to do that on AWS. We're then going to talk about one new product offering that we launched last year at reInvent that has gotten a lot of new features called AWS AppSync. We'll then go into a new set of tools called AWS Amplify that are really a few things. There's a service. There's also a set of open source tools that you download to your machine and that you can contribute to on GitHub. And then finally, we're going to talk about how it all fits together. And then at the risk of my own health, I'm going to switch over to my computer, and I'm going to try to build an app in front of you. So what does every app need? These are just a few things. There's more. But one of the first things you have to think about is user management and authorization. That includes things like how are your users going to log in, as well as how are you going to authorize users to access certain subsets of data that you operate on in your application. In this instance, we're going to be building an app with a real-time API. That implies that we're pushing data down to the client and not just doing the request-response model. We're going to need client SDKs and tooling. These will be things that, A, help you connect to the cloud from your application, as well as CLIs and other things to help you spin up those projects and then to manipulate the infrastructure in your application. And then on the other side, we're going to be talking about more deployment and operations things, such as multiple environments. You are likely operating as a member of a team. Every team member needs to have their own isolated environment so that you're not stepping on each other's toes. And then those need to be distinct from the environments that you're launching and test in production. We're then going to talk about hosting. So this is just simple web hosting. There's a new tool in AWS that we just launched last Sunday that's going to help you to do this. We'll be talking about continuous integration and deployment. This is really around when I make a change to my code, I want to be able to push it to Git, and I want to see my application get built and deployed to my infrastructure without having to do much else. And then we'll be talking a little bit about analytics and how you can instrument your applications with analytics using certain AWS services. So how do we get there? There's a lot of services. There's over 100 services in AWS now. We have Amazon Cognito user pools that is going to basically fill in that user management and authorization role for us. We've got AWS AppSync that both is a request-response model, but also provides real-time data publishing through a pub sub, and it acts as a data broker for you. We've got the AWS Amplify framework. The framework itself is going to help you both spin up applications using a CLI. It's going to help you connect to the cloud, and it's also going to help you to, you'll see, do CI/CD. We've got the Amplify CLI. That, again, is part of the Amplify offering. It's going to help you spin up the project primarily, as well as manage multiple environments. The Amplify console is a new offering that does CI/CD and web hosting for web apps. And Amazon Pinpoint, which is an analytics and user targeting service that you can use both to get information about how your application is being used, but you can also create groups of users and target them with push notifications and other things. So first, we're going to look at AWS AppSync. So what is AppSync? AppSync is a managed serverless GraphQL gateway on AWS. It allows you to define the shape of your API using the GraphQL schema definition language, or SDL for short. It allows you to attach data sources that reference data stores that live in your AWS account, and also associates that data source with a role that you have control of so that you can limit what operations AppSync has permission to call on your behalf. And then you write resolvers using a templating language that allows you to basically manipulate information from the GraphQL domain into the native language of whatever that backend data source is, whether it be DynamoDB or Elasticsearch or others. And it's also a real-time data broker. So this basically just serves as a pub sub engine that you get without having to configure anything else. And it makes real-time information really easy to implement on top of AppSync. And that uses MQTT over WebSockets. So here's a diagram of what a basic AppSync API looks like. There's a lot of blocks, but the things to notice are that there's the AppSync, where you've got there's three important concepts. There's your schema, that is the shape of your data. There's resolvers, that is basically the business logic that tells us how to manipulate the information that lives in your AWS account. And then, as I mentioned, there are data sources, which you can think of as a container that points us to a resource in your account and then associates it with a role so that we can access information and you still have all the security, you have all the power to strip down security and access so that you don't give us excess power that you don't want us to have. So something else that's really important in this whole conversation is a new technology called GraphQL. This is the definition of GraphQL from graphql.org. So GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your API. It gives clients the power to ask for exactly what they need and nothing more, makes it easier to evolve APIs over time, and it enables powerful developer tools. So I'm just going to quickly jump into this, and we'll go into this in more detail. So what does it mean for GraphQL to be a query language for APIs? It gives us a strongly typed language that we can use to interact with information on our server. This is different than a pattern that you might see in RESTful APIs, where you use resources URIs in order to denote what resources are in your API, and then you just use HTTP concepts in order to access those things. GraphQL is actually a full-fledged language, and it has 3 base operation types. There's queries that read data. You could think of it like a GET request. There's mutations that augment data. They're your put and your patch and your posts. And you've got subscriptions that stream data, which there's no real concept in REST, but you think of it as a WebSocket connection. So next, it's a runtime for fulfilling those queries with your existing data. So there's the query language that you use to access information and to request information from your client apps. There's also a runtime component that basically defines how a GraphQL server should run, and then it defines the logic for how you resolve information from backend data sources. The cool part about this is that it doesn't actually imply that you're using any particular data source. So you can put a GraphQL API in front of pretty much anything you could store information in, and then you have the common interface from the client that you're talking GraphQL, but then GraphQL can talk to DynamoDB or Neptune or RDS or Elasticsearch or any older API that you guys are maintaining, and it'll just work out of the box. And then you can see that the query comes in, it runs through the runtime stitches all the information together, and then it returns a response in exactly the same shape that you're expecting it. The next piece, it's a complete and understandable description of the data in your API. So this is the schema. So this, you can see here, is an example of the schema definition language. At the root of it, you define the types that handle your root operations. So at the top, you see schema, and then you see lowercase q query points to capital Q query. That capital Q query is just an object type in your schema that you can define however you want. You can change the name of it if you want. But it basically is defining what is the root of your application's graph. From there, you strongly type. You have fields and object types. Types can take fields can take arguments, and they return different shapes of data, whether it be in a num or an object type, an interface, or a union. And then this is strongly typed. So as you're writing your queries, you're going to see that GraphQL will do validation based off this type system. It gives clients the power to ask for exactly what they want and nothing more. This is basically a response to overfetching. So what this does for you is it makes it so you don't have to overfetch. So traditionally in a REST API, you might ask for some amount of information. If you've got like a master detail view, you might only need to show the title of something, but you might get back 20 fields for every single object, which is going to add a lot of overhead to your network. So GraphQL is really optimized to work in low network or lesser network availability, and that's part of its design. Another part of this is that it's explicit, and every client has to ask for exactly what they want. And this becomes important later when you talk about evolving APIs, because you can build analytics and figure out exactly what fields in your API are being used. And when you know exactly what fields are being used, you can deprecate fields with a lot more confidence. It makes APIs easier to evolve over time. This is pretty much what I was just talking about, but they actually have support baked in for, you can see here this @ sign, that's called a directive. The @ deprecated directive actually came with the first version of GraphQL when it was open sourced, and it's just a common way that people use to express information down to clients saying, hey, we want you to move off this field, and then you can watch as the number of clients that are consuming that field tick down to 0. Once those number of clients tick down to 0, you can remove that field with confidence and know that you're not going to break any clients. And the last one is that it enables powerful developer tools, and this is why we're here. So we're going to show you some cool developer tools that we've been working on. There's a number of other open source tools. One's called, one of the most popular ones is called GraphQL. It's an IDE for GraphQL, and it's something that almost everybody that works with GraphQL uses. So next, we're going to talk about Amplify. So Amplify has really become hold on. Sorry, I'm being told I should reopen my slide deck. Let's see. Let me open this one. Oh, sorry about that. OK, let me jump ahead back to where we were. OK. All right, we're back. So what is Amplify? Amplify is really a set of technologies. There's Amplify Framework. That is a set of client tools that you actually download to your device that make it easy for you to consume AWS services from your web or mobile app. There is the cloud service, which is Amplify Console. That's what we just launched on Sunday. It's a kind of no-nonsense CI/CD and web hosting solution for web apps and projects that use Amplify backends. And there's a set of developer tools that are basically kind of encompassed in the CLI, where the CLI is going to help coordinate all of the moving parts of this, and it's going to make it really easy for you to jumpstart projects, manage those multiple environments, and deploy that information to the cloud, deploy your infrastructure to the cloud. So what does that look like? Here's an example flow, and we're going to see this in the demo later. But it's a couple simple commands. You'd say amplify init. That's going to initialize an Amplify project for you. You'd then say amplify add auth. That'll add an Amazon Cognito user pool, and it'll have all these best practices baked in, so you don't really need to think so much at the onset about what are all the fine-tuning that I can do. And then there are escape hatches later that you can use to fine-tune things once you have gotten started. There's Amplify add storage. This will do things like create S3 buckets. It'll create DynamoDB tables for you. And you've got another one called add analytics that'll add the pinpoint project. Add API is going to create a GraphQL API on AppSync. It also supports API Gateway. And then Amplify push is what you use to basically compile all of those resources together, and then it'll deploy those resources to the cloud using CloudFormation. So the GraphQL transform. This is a new project that came along with the Amplify CLI that we've been building that is all about allowing you to rapidly build and prototype applications on AWS. And it allows you to declaratively define data models using the same GraphQL schema language that you would use to define your API's data model. But it's got some cool tricks cooked in that'll make it really easy to kind of generate code really fast. And the way that we do this is through using GraphQL directives. So this project is open source. I'll show you it on GitHub. But what you do is you write things called transformers. A transformer defines a single directive. In this case, we have some that come baked in, but you can build your own, like @model, @auth, @connection, @version, and @searchable. And then those transformers manipulate a context in the tool chain that then, when you see those directives in an input document, it's going to transform it and spit out a CloudFormation document that implements that data model. So that was a lot of words. Let's look at a few examples. Here's the first one. It's the simplest of them. Basically, what this is going to do is when I run Amplify add API, it's going to say, hey, do you have a schema? I'd say either yes or no. It'll open up that schema document in my terminal or in my code editor. And then if I put this type post @model with 2 fields of ID and title, what it's actually going to do is it's going to spin up a whole backend that just has one type in it, which is going to be stored in DynamoDB. So once you add this to your API, you'd run Amplify push, and then you're going to get that same application architecture that I showed you at the beginning, where you've got a new DynamoDB table that's there to hold your posts. It's going to automatically configure that data source with a scoped down role that only gives the minimal amount of access that we need in order to do common operations. It's also going to go ahead and generate code to implement CRUD resolvers that allow you to create objects, update objects, delete objects, get objects, and list objects. And then it's going to put all of the schema in place that you need in order to get things like pagination, filtering, ordering, and things like that where all you had to do was say type post app model, and it's going to generate all of the more advanced stuff that you would otherwise need to have done yourself. So once you've done that, this is what you can do. So your API is ready. I just had that one simple type annotation. Then I'm able to create objects using create post mutations. The input arguments are going to be generated on your behalf by looking at the type declaration that you gave. In this case, I'm just giving it a title. It's going to allow you to get objects by ID. That's a get single object. It's also going to allow you to list and paginate objects. So if you, when I first put that type post, I never told it that I needed pagination. I never told it how to implement pagination. It's just going to go ahead and compile out a really common pattern that allows you to do pagination, where you can get 10 objects, and then you can move through using cursor-based pagination. It'll also generate an update post resolver that allows you to basically do a patch operation where you're not going to overwrite everything, but you're just going to update certain fields in that object. If you have 100 fields in your object and you just want to update one, this is how you do it. And it's also going to allow you to delete objects. And this one would delete the object with ID 1 that we just created. So that's the model directive. The model directive allows you to basically define types that you want to have as first-class entities in your API. It's going to create the table to store it. It's going to configure all the things you need in order to interact with it from AppSync. And then you can actually configure things like you can rename the names of the mutations. You can turn mutations off and turn subscriptions off or queries off. And I can show you that later. But it's more fine-grained than just saying app model. The next directive we'll talk about is the auth directive. So the auth directive is basically designed to work for particular use cases that we've seen that customers have that they deal with often when they're building applications. And the first type of auth that we've implemented was called static group authorization. So this is a type of authorization where you can just say, I've got users in my user pool. I have a certain subset of those users that are in some special admin group, and I know them, and I'm the admin, so I'm able to add them to that group. And then you can just say, type post is able to be operated on by the admin group. So this is one where every object in that table is now going to have access, the person in the admin group will have access to that object. So this is basically table level authorization. The way that it's implemented is it actually goes, and when we're running, we do a lot of code generation in this tool, where we're going to code gen the resolver code, and it's actually going to code gen the authorization check into the resolver without you having to think about it. The next type of authorization is dynamic group authorization. Dynamic group authorization, as opposed to static group authorization, says that every individual record is able to define the set of groups that are able to access it, and then we're actually doing row-level authorization instead of just a table-level authorization. Again, this is going to be implemented as resolver code, and you can designate which field in your model type you want to hold that information, so that as you're creating objects, you can say, these groups are able to access this particular object. And then if you're trying to, for example, create an object and say, I'm not in the admin group, and I'm saying that this particular post should be able to be edited by an admin user, it's actually going to reject you and say, hey, you can't create that thing because you're not in the admin group. The next is ownership authorization. So there's ownership authorization, and there's two types of ownership authorization. There's single owner authorization, and there's multi-owner authorization. In this instance, you're seeing multiple owner authorization. This operates similar to dynamic group, but instead of it being based on the group, it's actually based on the individual user's credential. And you can actually overwrite what that credential is. So if you're using Cognito user pools, you can have a custom credential that you use, or that you somehow fill in from an AWS Lambda function or otherwise, and then you can basically implement your own authorization schemes using this ownership authorization. And this, again, is going to be a row-level authorization tactic. And then you can combine these rules. So currently, there's only support for ORs. So this is going to say that either you're an admin group or you're in the editors group. But we'll have support for ands and other more complex combinations of these coming soon. But you can add these things in series, and then you can also specify which mutations and which queries you want to protect with these. So I could say that admins are able to have full access, but then editors are able to create and update, and that's it. The next one is connection. So this one's really interesting because what it allows you to do is it allows you to add relational capabilities to otherwise non-relational data stores. And eventually, it'll allow you to connect different, to add relational capabilities between data stores. So what this is doing is it has support for DynamoDB. So I've got my type post. It is itself a model. That's seeing that it's the top-level entity. We then have type comment, which is itself a model. And then if you see that they have two connection fields and that they share the same name, what that's doing is saying that those fields are either side of the same relationship. So the post comments field is going to list all of the comments for that post. And then the comment post field is going to go find the parent post that owns that comment. The way that this is implemented under the hood is, in this instance, it's a one-to-many relationship. When we see a one-to-many relationship, we're actually going to go ahead and create a global secondary index on that comment table that has the hash key of the post ID so that we're able to efficiently query that index to find all of the comments for a particular post. You can optionally provide a sort key so that you can say, I want these comments to be ordered by the created at timestamp, and then you can move forwards and backwards throughout that relationship. And then you can see what's actually happening is it's going to add new resolvers. So before we had the mutations and the queries for the entities themselves, this is actually going to add a resolver to the post.comments field and to the comment.post field that know how to go query the other table. And in the instance of post.comments, it's going to use a DynamoDB query operation on the GSI. And in the comment.post field, it's going to do a DynamoDB get item operation against the post table. So how do you use connections? It's just like everything else. Here you can say, I want to get a post by ID. That comments field has a resolver on it now, so it knows how to go fetch all that data. And then we're also going to add pagination to that without you having to think about it. So if you look back here, it's just I'm saying comments is a list of comment. Once that schema is compiled out, it's actually going to return a comment connection type that you don't have to worry about, but it's going to implement that connection for you and allow you to do pagination. You can also provide filter arguments here that I'm not showing, and then you'd be able to paginate through this set until the next token returns null, at which case you're at the end of the set. The next one is the version directive. So the version directive is particularly useful when you're trying to build offline use cases. The reason for the version directive is that it's going to implement context detection and resolution for you. So what this means is if I'm going to go create a post, I'd have input, title, a new post. It's going to have the ID, the title of version, and then if you see that version's automatically going to be ticked to 1 when I run the create mutation. I can then go ahead and run an update post. And when I'm doing an update post, there's a new required input field called expected version. I have to provide that version field from my client, and if that version field is the same, it's going to be great. And then you see that the version field is automatically ticked up to 2 because I ran that update post operation. Now, meanwhile, while I was running that update operation, there was a second user that fetched the object right before the update, but that then went offline. And then after coming back online, he tries to run that update that he did while offline. And what's going to happen is he's going to have that old version of that expected version. He's going to try to be updating that same object, but the expected version is going to be 1, while on the back end, it's actually already been updated to 2. And what it's going to throw is a conditional update failed exception so that your client can actually handle that and then either decide to update the version and then commit it. In that case, it'd be basically the last write wins. But you can also use a Lambda function and other logic if you want to basically handle that conflict and then merge the two results back without endangering overwriting something that you don't want to overwrite. The next one is searchable. So this one is more advanced. What this does is it takes a model and it'll actually stream data of that model type into an Elasticsearch cluster running on Amazon Elasticsearch Service. The way that it does that is it's going to create a DynamoDB stream off your DynamoDB table that's holding your model object. We're going to provision a Lambda function that listens to that DynamoDB stream, and it's going to move that information into an Elasticsearch instance that was actually provisioned for you as well. Then it's going to create one more resolver, in this case the query.searchPosts field, that is going to use an Elasticsearch query that can be parameterized from the client. So we'll see an example of how to use it. But it's going to allow your client to do full text search and eventually analytical queries against that Elasticsearch cluster. And here's how that would work. So after I'd create an object, as soon as I create that object, it's going to get fired through the DynamoDB stream. It's going to be handled by Lambda and then indexed using Elasticsearch index operations into the Elasticsearch cluster. And then from the client, you can just run this search post that has a filter input that was generated for you based off of the shape of your object type. So because our post type had a title in it, we went ahead and added a specific strongly typed filter for that title field into the search post's filter input type. Here you can then say title, and there's a few operations that are supported. In this case, I'm going to use the match operation, and I'm going to be able to find all of the posts that use the Elasticsearch match operation, where the argument is new, and it's going to give me all of the posts that contain that new term. So the next piece that was AppSync and the GraphQL transform support in the Amplify CLI. We're now going to look more at the Amplify library and the other Amplify offerings. So like we said, it's a simple declarative configuration. You design your model. That then pushes it into the cloud using CloudFormation, and you can just say app model, add searchable, all those things. It works seamlessly with the Amplify framework, so this is actually bundled as a part of the Amplify CLI. And then all the data is stored in your AWS account. And that's great because then you can use all of the other things that you have access to within the AWS offering to manipulate that data. You can do ETL. You can do all the other things that you'd think of. And you have complete ownership of your data. So now we'll talk about the Amplify library. So the Amplify library allows you to easily connect services to web and mobile apps. And there's a number of categories. So we've seen the API category a little bit. Analytics is how you can add a pinpoint project and then easily instrument your application to use that pinpoint project. Auth will add the Cognito user pool and has built-in components that will implement basically your sign-in, sign-up, and MFA flows for you. There's function, which can create Lambda functions, storage, which is both S3 and DynamoDB, and more. There's interaction-based categories and other ones, and they continue to roll out. So the Amplify library is all about creating simple abstractions for common customer use cases. So part of that is that it's an opinionated implementation of those common use cases. And we'll see kind of how that works. And then there's another piece that it started as a JS implementation. We actually have support for iOS and Android now. And then within the JS implementation, we also have special support and special wrappers that are specifically meant for React, React Native, Ionic, and Angular. So here's an example of how you'd get started with it. The first thing you'd do is you'd import that Amplify library. You'd get the AWS config file. So when you run Amplify push, it's actually going to create that aws-exports.json file in the root of your project directory. And then all you have to do is run configure. That's going to tell Amplify how to find your user pool, how to find your pinpoint project, how to find your GraphQL API, and all of that with one line. And then once you've run that Amplify configure command, you're able to start using the other parts of the Amplify library. So here's one that is pretty cool, and we'll see this later, but it's just an Authenticator component. So this is an example of how the framework-specific wrapper for React would work, is I can just import this Authenticator component, and there's a similar concept for Angular, and then I can just render that Authenticator component, and because I ran Amplify configure, this Authenticator component is going to know how to configure that UI in order to work with the particular settings of my user pool. So if you have MFA turned on, it's going to handle MFA. If you have email as your primary mode of logging in, it's going to know how to show that. And then it's going to implement a really easy-to-use create user flow, a really easy-to-use login user flow. And then there's a lot of customization options. So here you can see that I'm having a specific handler for doing the on-state change. This is when after a user's logged in, I might want to take that logged in credential and then put it into some Redux store or into a context in my React application so that other components in my application can use that logged in user session. You can see that it's got an Amplify config. That's the same AWS exports. You can even do custom error messaging. So this is just a function that when a specific error is thrown, if you want to provide special branding around those error messages, you can basically intercept those error messages and then show what you want. And there's more here as well. You can do custom styling. And there's a lot more docs on the AWS Amplify documentation site. The next component is the connect component. So this is a really easy way to connect application data from your GraphQL API into your React application. There's similar concepts for Angular and for iOS and Ionic. But basically what this is doing is it's allowing us to provide a query. That query is going to be basically the base query that says, give me all of the records that I'm going to need to render this view. You can also provide a subscription query. So a subscription query you would give is, in this case, you can see I have my get conversation query that's running, and then I'm providing my on create message subscription. The reason for this is that on create message subscription is actually only going to yield new messages for the particular conversation that I fetched. So once I've fetched the conversation, it's going to open a subscription, and then as new messages appear that are being pushed down to the client, I'm going to be able to merge those new messages into my conversation without refetching the conversation, which is great for a network. Then you can see it's using render props in order to provide that data to your application. You can see it's going to have nice handlers for a loading message saying, hey, this base query is still running. You can render a spinner. Or if something goes wrong and an error is thrown from your API, it's going to give you an easy escape hatch and then allow you to render that error. And then once the data is there, that data is just going to be available. You can go find the data that you need, and then you can render the messages. So this is actually how I implemented a chat message view in a demo that I built. Another useful function is this is just importing the API category from AWS Amplify. This is a lower level implementation of the GraphQL client. In this case, we're not using any special React-specific wrapper. It's just allowing us to take a query that we have. In this case, it's the create message mutation. And then we can call that operation, get a response back, and do anything else that we need. And then you can provide the input, as you'd see here. And then finally, we'll look at analytics. So this is the analytics category of the AWS Amplify library. It allows you to, it's more use case driven, so a common thing people need are start session and stop session. That's implemented as a timer, but you don't necessarily need to think about how to parameterize that timer. And this is just another easy way of adding instrumentation and instrumenting analytics to your app. There's a lot more options here. You can have custom events and others, and all of these things are going to be pushed into your pinpoint project so that you can start targeting your demographic users, as well as seeing usage data and usage patterns within your application. Another cool part of the Amplify offering is Amplify Code Gen. So this is really important for applications that are using strongly typed languages like Swift for iOS and Java for Android, and even for TypeScript and for Flow if you're trying to put typing on top of your JavaScript. And how this works is once you've defined your application's schema, either using the GraphQL transform or just other means, you can just add code gen to your project. And then when you run the code gen utility from the Amplify CLI, it's going to go introspect your GraphQL schema, and it's going to create strongly typed native types within your client app so that you can start using the strongly typed nature of Swift to figure out what, it's going to map the database objects to objects in your application. And then you don't necessarily have to think about writing GraphQL queries as much. You can just say, I know that there's a list posts query in there. We'll generate that type for you, and then you can operate using traditional SDKs that you'd think of if you were going to be using Swift or Android. And the last thing before the demo is we'll talk a little bit about multi-environment support. So this is a new feature. It's in beta. You can get it today if you get the multi-env of the Amplify CLI. And what it's going to do is it's going to allow you to have multiple environments so that different users on the same team can operate on the different, basically completely separated environments in their own AWS accounts. You can then have an environment for test and prod. And you can even map those environments to Git branches and then deploy those things through the Amplify console. And then with that, I'm going to dive into a demo and show you basically everything we just talked about. So part of this is you're going to just bear with me because I am going to do some CloudFormation provisioning and we're going to be digging around, but it does take a few minutes. So here what I'm going to do is I've got a base application. This is just a React application that I started with create React app. There's nothing special. You can see in the package.json there's almost no dependencies outside of React and the AWS Amplify library, and then the AWS Amplify React wrapper for React. So what I'm just going to do is I'm just going to go ahead and run Amplify init. You guys see this? Let's blow it up. So when I run Amplify init, it's going to ask me for a name for my application. I'll do ChatQL React demo. And then it's going to ask for an environment. So this is my local environment. This is something that I want to be able to operate on and change without interrupting anybody else, so I'm just going to call it personal. It's then going to ask, what is your code editor of choice? I tend to use Visual Studio Code now. It's going to say, what are you building it in? I'm building this application in plain JavaScript. And then it actually already knows that it's a React application because it looked at my package.json and saw that we depended on React. It's then going to say, where's your source? That's fine. That's fine. What's my build command, my start command? And then it's going to ask me what profile do I want to use. And this is the same type of profile that you'd be used to if you had the normal AWS CLI. And I'm just going to have one. I have one Amplify that's scoped for this, and I'm going to go ahead and use it. So what's happening now is it's actually deploying a root stack into my CloudFormation service in my AWS account. And that root stack is basically going to be the entry point for all of the other resources that I create through this tool. The reason that we have a root stack is just because of CloudFormation stack limits. And so we use nested stacks in order to add a lot of different resources without running into those. So you can see here, created an unauth role, an auth role, a deployment bucket that it's going to use to push assets to, and then just the stack itself. So the next thing I'm going to do is I'm going to start an add auth. So Amplify add auth, add auth is going to go ahead and provision that Cognito user pool for me. And it's going to either ask, do I want to use the default configuration, which I'm going to say yes. But you can say no, and then you can tweak this thing to your heart's content. And that went ahead and added a new category to my Amplify backend directory. So you can see auth right here. I'm going to do the same for analytics. So this is going to go ahead and provision, or at least configure, the pinpoint API. And then it's going to ask for some smart defaults. I'm going to go ahead and say yes. And then last thing I'm going to do is I'm going to add an API. So this is where things get a little bit more interesting because we're going to start seeing the GraphQL transform. But here it's asking, would you like a GraphQL API or a REST API? I'm going to choose GraphQL. It's going to want a name. So I'm going to give it that. And then it's going to say, how do you want to authorize this API? Because I already added my user pool, it's going to know how to configure that. So I'm just going to say, I want this API to be authorized with my user pool. And then it's going to say, do you have an annotated GraphQL schema? I do, but I'm going to say no, just to show you. It's going to say, do you want a guided schema creation? I'm going to say yes. And then it's going to give me a few default options here. I'll just start with the simple one to show you what it does. It's going to say, do you want to edit it now? I'll say yes. And then I just open that file in my text editor. That file is right here. You can see it under the API category, under the project name that I just created, in this simple schema.graphql file with a single model declaration. So what I'm going to do is actually take this more advanced one that I've already built, and then we'll look at it. And I'm going to go ahead and start it because it will take a few minutes to deploy this to CloudFormation. So I'm just now going to run amplify push. And then it's going to say create, create, create. I'm going to say yes. And now it's going to start deploying that, all of those CloudFormation resources into my AWS account. So while it's deploying, we can kind of take a look at our schema. Oh, I hope I saved that. We'll find out. It's going to take a look at the schema of where you can see I've got type user, I've got this type conversation, I've got type message, and I've got type convo link. So what this is doing is I've got users. Users are going to have the ID that is equivalent to their username incognito. I have conversations. Conversations act as a parent type to messages. And they also have an associated list of convo links. So the reason we have this list of convo links instead of just list of users is that we're actually going to implement a many-to-many relationship here between users and our conversations so that you can implement group chat if you would like. We then have this message model that allows the owner to create. Basically, only the owner of a message is able to change that message. You can see I'm turning off subscriptions and turning off queries because I don't want to be able to read messages directly. I should only be able to read messages through conversations. And then I've got this convo link type, which is basically implementing the join table that we'll be using to associate many conversations with many users. And you can see here we're using the connection field to do that. And then finally, we've got this subscription implementation at the bottom. So what this is doing is allowing me to define more fine-grained subscription logic. So in this case, I have an onCreate convo link and an onCreate message. And then the arguments that I'm passing to these subscriptions are actually really important. So if you'll notice, this convo link user ID is the same name as a field in my convo link type. The AppSync implementation of subscriptions, in order to, there's a problem in subscriptions if you're in naive implementations where if you have 1 million connected clients and 1 million messages being published, and you want to be able to authorize those messages and route the messages only to the connected clients that are looking for those messages, if you had to run logic per message per client, you'd see that that's obviously problematic. So AppSync has a clever way of, when you provide these arguments, it's going to, once you run that subscription query, it's actually going to return an MQTT topic that's already pre-authorized at connect time, and that's scoped down to only give you the messages that you care about based off of the arguments that you passed to the subscription when you first created the connection. So in this instance, you'd see on create message, I'm passing this message conversation ID. This message conversation ID is on the message model, and then that's going to be doing an equality statement to say I should only be getting the messages for that particular conversation, which is how we're going to implement the chat view in our app. So while it's going, I'll just show you the CloudFormation so that you can see what's going on. Oops. So here you can see I've got a new stack, create React demo. This was the root stack that was created when I ran Amplify init. I then have a stack for this one is for auth, I believe. Yep, so this one is for auth. This stack is going to be implementing my analytics, which is going to be creating a pinpoint project. And then this is my API category. So this is where it's going to be creating my AppSync API, all of the data sources that associate the new tables that I created. It'll actually create the DynamoDB tables for me as well. It'll create the IAM roles that are scoped down with a trust policy that allow AppSync to invoke operations against the DynamoDB tables that we're creating on your behalf. But then you have full control of this if you so choose. And then when this finishes, just a few more minutes, you can see what's happening here. You can see it's creating the data sources, the resolvers. It created the API key, a GraphQL schema, the Dynamo tables. Almost done. Oh, you know what? I don't think I saved this. I'm going to have to do one more update. Watch this. So I'll show you how to update too. So it turns out when I copied that schema in, I forgot to click save. And I'll show you how you change your schema then too. So right now, what this is going to have implemented, if you go to AppSync, is going to be that simple to-do model. Let's see. So it's going to be this one. You can see the schema here. So this is the to-do. What I'm going to do is now I'm just going to do this. I'm going to say Amplify API push. It's going to know that that thing updated. Oh. Uh-oh. Hold on, let me change one thing. Then I'll just make this. OK. Let's do that one more time. I'm going to push my API. There we go. And then that's going to compile it. And now it's actually going to rerun just the update on that one CloudFormation stack. So it's going to do the base. And then this is going to start updating. And we're going to be able to see our schema's been created. So here, this is going to take just a few more minutes. It's going to go do this same thing. It's going to create the DynamoDB tables. And then we'll continue going. So while it's going, I'll show you it running on my local box. But what I'm going to do now is I'm actually going to start preparing for our CI/CD. So I have an empty Git repo here. There's nothing in it. What I'm going to do is I'm going to go ahead and add all of my files to it. And then what I'm going to do is I'm going to make a few branches. So first I'll make a dev branch. Then I'm going to make a prod branch. I'm then going to check out that dev branch. And I'm going to go into my header, and I'm just going to change one piece of text so that we can see that things are changing. So in my app nav, I'm going to go in here. This is just React. I'm going to say ChatQL in development. I'm going to add that. And then I'm going to go and check out my prod branch. And I'm going to change this to production. So now I'm going to go ahead and push this into my GitHub. So I'm going to say git push origin prod. And then I'll do the same for my dev. in just a minute. There we go. And then what we'll see is that we now have this project in this fresh repo with 2 branches. We have dev and we have prod. So now, let's see how this guy's doing. This looks like it'll just take a few more minutes. As soon as this is done, I'll run my front end and we can see it working on my local host to show you what the application looks like. Let's see, almost there. Here we are. There we go. Cool. So now, almost there. If we go back to AppSync, I'm going to refresh this page, and we're going to see that our schema has actually changed. So now you can see here's the schema that I actually wanted. I've got my Convo link type. There's create conversation input, create Convo link input, create message input, all these things that I didn't necessarily need to think about, but that are best practices. And then you can see on the right, we have resolvers that were generated. So I can go to my query. We have get user, list user, get Convo. We have mutations, create user, update user, delete user. And then you can even see that in here, this is the templating language that you can use. And these are the authorization checks that were automatically code genned on your behalf in order to implement that ownership authorization that we put on the user type. So now I'll jump back. And this guy is just about done. And I'm just going to go ahead, and I'm going to go ahead and run my application locally. And then while that's running locally, I'll show you how we're going to start pushing that into production as well. So I'm just going to say npm run start. This is going to start the React development server. It's going to open that in my browser. And then while that's loading, I'll show you. So now we have, this is going to be running locally. Once we have that thing running locally, the next step is going to be how to deploy that to the cloud. The way you do that is using the Amplify console. Here I'm going to show you how that works. I'll click deploy. I'm actually going to connect my GitHub. I'm going to click next. I'm going to say it's going to then list my GitHub repositories. I'm going to select my ChatQL demo that I just added. I'm going to select my dev branch first. I'll click next. And then what this is going to do is it's going to already know how to deploy this thing. So because it's an Amplify project and it knows that it's React, it's got a build script that's already there to run React applications, to package it using the production build. It's then going to know how to upload it to S3, deploy that through a CloudFront CDN, and then it's actually going to use Lambda at Edge in order to do atomic deployments. So I'm going to go ahead and give it a service role. I'll click next, save and deploy. And then what's going to happen is this thing's going to start building in the cloud. It's going to upload that thing to S3. And then we're going to have a fully hosted web app with a live HTTPS domain that we can hit immediately. And then from there, you can start doing more advanced things, like using rewrite rules if you wanted to nest a static blog under your site. You can also provide your own Route 53 record if you want to change your domain. And you have full control of that. And it's really just no-nonsense CI/CD and hosting for you. So here we've got our dev environment. It's going to provision. This is going to create a container in order to run our build. It's then going to go through the build step, which is going to build both our Amplify backend. It's then going to deploy that Amplify backend using CloudFormation. It's going to build our React application using a production build. It'll upload that to S3. It'll then use the Lambda at Edge to swap the pointers to go to the new build every single time it happens. And then all I have to do subsequently is do a git push. So when I change my application, I'm just going to check it into Git. I'm going to do a git push. GitHub's going to fire a webhook to the Amplify console, and it's going to start a new version of that build. And we're going to be able to see it in just a few minutes after it's gone. So now we can jump back to our local ChatQL React just to show you. So this here is the Authenticator component. I can show you in our home directory, in our home here. This is this. I did not have to implement any of this at all. I just put this Authenticator in there. And now I can just go ahead and create a component or create a user. I'm going to give it an email. This has MFA turned on or it makes you confirm your sign up by default. That was part of the default configuration. So I just got a verification message through my email on my phone. I'll click confirm, and then I'm going to log in with that user. And then I'll also actually open this in a new tab. I'm not logged in yet. I'm going to log in as a different user. Oops. There we are. Oh, got to create it first. And then I'll use another email. I'm going to then get this push to my phone again. I'll update with this. Here we go. There we go, just got it. I'm then going to go ahead and do 877.912. I'll log in as Zach this time. And then what we're going to see is I'll open these things left to right. You can see that this just already knew that Zach was there. That was pushed an update over a subscription. I'm going to click on here, open a conversation between Michael and Zach. You can see in the bottom left, that was pushed to conversation in real time. I'll open this, and I'll open this, and then we can start chatting. There we go. So there's just a really simple, that's GraphQL subscriptions using the connect component. And then at this point, what we can do is jump back to the Amplify console and see how our build's doing. So here we can step through it. We've got our provision step is done. We first cloned the repository from GitHub. We're now building our backend. So what this is doing is when I said that this is the dev branch, it's actually that created a new Amplify environment. So this is going to be a completely distinct set of resources that doesn't share the same user pool. It has its own entirely different set of DynamoDB tables. And then those are also going to be deployed through CloudFormation. So if I jump here, you're going to see that there's now another set of ChatQL React demo. And this is going to be my development environment. So if you go here and you can look into the parameters, this is going to pass an environment. This one is dev. But then back here, this one is going to be personal. So then the only thing that's really changing is this environment variable. And then that's going to create a completely distinct set of resources. So you can see this is going to take another minute. But as soon as this is done, we're going to have at this URL our application hosted. So this is just before, we haven't gotten to the front-end deployment step. But then as soon as this is finished, we're going to have a full website on this dev dot. And then if I wanted to go add my production branch, what I would do is go back to my apps. I'd connect a new branch. I'd choose prod. I already have a dev one, so it's not showing it. I'd click next. It's going to be able to do the same thing with the build script. I'll click next and save and deploy. So now that's going to start building my production branch. And then as I want to move things from my development into production, all I have to do is merge my feature branches into dev. I then merge my dev branch into my production branch. I do a git push, and then your website's going to get updated automatically. There we go. OK, so this is going to take a few more minutes, but I hope that helped show the power of this Amplify console and the Amplify framework, as well as the Amplify CLI. This application, other than the part of writing the React application, was totally fresh. We had no backend resources. And I hope that kind of showed the power. You can see that there's more here on the left. And since this is just going to take a few more minutes, I might just open up the floor to questions. Anyone? Yep, so we can go look at Dynamo. So if we go look at DynamoDB, I have a ton of tables, but you can see here we've got a number of them, and you can see the names. So messages, for example. So we've got message, and I've got a couple dev, but we'll look at personal, because I know this is one I created just now. If you look here, it's going to have these GSIs already created. Oh, that was global tables. Sorry, I clicked on the wrong thing. Indexes. There we go. So here you can see there's actually two GSIs that have been created. And the reason for that is if I go back to my schema, the relationship between a message and a conversation is a one-to-many. And the relationship between a message and a user is also a one-to-many. You can then see even on the convo link, the convo link would not have it. Actually, no, it would. So if I go look at convo link, the same thing. So all of these are the same. But you can see here, there's GSIs created on the convo link. this is what's implementing the many-to-many relationship between the conversations and the users. And then again, as you can see on one of these, you can provide a sort field as well. So our messages in a conversation are going to be automatically sorted by the creator of that timestamp, and all I have to say is this is the sort field. Yep. And then also there's a limit of 5 DynamoDB global secondary indexes on a table. We're also looking into using a different pattern that will provide less filtering ability, but it'll get past that limit, so you can have any number of relationships using an association map model instead of having this global secondary index query pattern. And then you can use batch gets. Cool. Any other questions?
On the DynamoDB design, say we did not want that design from Amplify, what other ways you can implement your own
Yep. So this is basically a tool. The GraphQL transform in particular is a tool for getting you there quickly and kind of starting from the GraphQL schema. But you can turn this off just by removing the directives. So once you remove the directives, you have the full power to have like normal AppSync capability, where you can just say, I already have a DynamoDB table. I don't want you to provision one for me. Then you can just add the data source, and then that's also part of the CLI. You'll be able to basically take tables that you already have. You can provision tables yourself using your own CloudFormation stacks, and then talk to those tables using AppSync as well. So yeah. Yep, same with RDS. So RDS support launched in beta also this past week. Basically, there's a new, if you go to AppSync, there is a new type of data source. So if I go to data sources, I can create a data source, and then now you'll see that there is a relational database option here. This is technically in beta because the support from the RDS team is very new. But here, it'll basically allow you to run SQL queries from AppSync against RDS serverless Aurora, and it uses a new HTTP interface that was just launched last week. Yeah. And then the other new part of the AppSync console is you'll see that we released a new feature called pipeline resolvers. Pipeline resolvers, if you've used AppSync, traditionally a resolver was a single operation against a single data source. Pipeline resolvers allow you to run multiple, what we would have previously called resolvers, but are now called functions, that allow you to have multiple operations against multiple data sources. And one of the most common use cases for this is if you're imagining that you have this create message mutation, you likely want to have an authorization check that says only users that are a part of a conversation are able to create that message. Before, you had to do a little bit of hacking or use a Lambda function to do that. Now you can actually run in the same resolver. You can say, go look up whether this particularly logged in user is a member of the conversation in question. If they are a member of the conversation, then you can allow the operation to happen, and it'll move into that create message step. But if you want to stop the flow because that user doesn't have permission, you can stop it beforehand and do more complex authorization strategies. And then we'll use that in the GraphQL transform as well to basically implement that out of the box. So you'll be able to have at some point in the future, be able to say, like, I want that exact use case. You should only be able to create this message if you are a member of its parent conversation. Yep. And that's the functions tab. Cool. Let's see if this is finished now. There we go. OK. So we've got deploy. We've got our backend beta. This is deploying the AppSync resources, or the Amplify resources. This is then going to do our production build. This is just using React scripts build, and it's going to have that production flag turned on, and then it's going to deploy. That's deploying it to S3. And then the verify step actually uses a headless browser to basically take screenshots of your application on various form factors, and then it's just going to show those to you every time you deploy. So you can see what your app looks like on an iPad or an iPhone or an Android phone or your desktop. Yeah, and then I can go to that site again. So if I go here, we now have check you out. Cool. OK. Any other questions?
Is it deploying the backend, like AppSync from here also?
Yep. So in this backend step, it's all through CloudFormation. So the same thing that I did when I ran Amplify push, it is itself running an Amplify push. And it did that by default because it knew that I had an Amplify project. But you can actually do any kind of backend deployment here. It's just part of that build spec. It knew that it was Amplify, so it used Amplify push. But you can deploy your own CloudFormation stack here. You can deploy your own kind of whatever you need. And there's more advanced. This ChatQL example is a pure Amplify version of it, but there's actually another version of it that was built by an SA at AWS that adds AI services and Lambda, and then it will also deploy that using SAM. So then you can do more advanced stuff here. It's just up to you. Yeah, this was just the default because it knew I was using Amplify. Relationship? So there's no like formal relationship between AppSync and API Gateway, but we have, so what people will often do is people actually have API Gateway APIs, and then a lot of them will proxy their API Gateway API through AppSync. And the way that you do that is AppSync has support for any HTTP data source. So again, if you go here, you can just see an HTTP endpoint. You can then use HTTP to proxy API Gateway, and you can actually even turn on SIG-before signing. So you can actually proxy AWS APIs itself. Yeah. Yeah. And this is really common, especially if you want to run like a Lambda and a VPC. So we don't have native support for VPC Lambda yet, but API Gateway does. So you can have API Gateway call your API VPC, and then you can access internal resources in a VPC through API Gateway through AppSync. Yeah. Cool. OK. Well, thank you, guys. Thanks for coming. I hope you enjoyed. Hope you learned something.